This is the only world we know of where the universe woke up and looked at itself. A blue planet, wrapped in ocean and air, alive with a billion forms of life. But it did not begin this way. There was a time when the Earth did not exist at all, no ground, no sea, no sky. Only a cloud of cold dust drifting between the stars. How did that dust become a living world? How was the Earth built, and the moon, and everything beneath your feet? To find out, we travel back 4.5 billion years, to the birth of the Sun and the violent making of our home. 4.6 billion years ago, in a quiet arm of the Milky Way, a giant cloud of gas and dust drifted in the dark, the leftover ashes of countless long-dead stars. For ages it simply hung there, cold and still. Then something disturbed it. A nearby supernova may have sent a shockwave rippling through the cloud. The delicate balance broke. Under its own gravity, the cloud began to fall inward, each part pulling on every other, collapsing toward its own center. And as it fell together, it began to spin faster and faster, flattening into a vast, swirling disk with a growing, glowing bulge at its heart. At the center of that spinning disk, matter piled up relentlessly. The core grew denser and hotter, squeezed by the weight of everything falling in around it. When the temperature reached 15 million degrees, a threshold was crossed. Hydrogen atoms began to fuse, and in a burst of light, the sun switched on. Our star roared to life, flooding the young disk with light and blasting out a fierce wind of particles that would shape everything around it. The sun was greedy. 99% of all the material in that entire cloud went into building the star alone. Everything else, every planet, was made from the scraps. That leftover 1% kept whirling around the newborn sun as a flattened disk of gas, dust, and ice. Everything in the solar system today was built from this thin, glowing ring. The disk was not uniform. Close to the sun it was scorching hot, and only rock and metal could survive. Everything lighter was boiled away. But far from the sun, beyond a boundary we call the frost line, it was bitterly cold. Out there, water, ice, and gas could endure in vast quantities. This single divide shaped the entire solar system. Near the sun, small worlds of rock and metal took form: Mercury, Venus, Earth, and Mars. Far beyond the frost line, planets could gather enormous amounts of ice and gas, swelling into giants: Jupiter, Saturn, and the frozen worlds beyond. Two families of planets, born from one disk, separated only by temperature. And in the warm inner zone, the third world from the sun was beginning to grow. It began impossibly small. Inside the disk, microscopic grains of dust drifted and collided, and static forces made them cling together. Grains became pebbles. Pebbles became boulders. Boulders became mountains. Over thousands of years, gravity took over, and mountains became worldlets called planetesimals. The largest of these had enough gravity to sweep up everything in their path, growing faster and faster in a runaway process of destruction and growth. The young solar system became a battlefield. Dozens of growing worlds, some as large as the Moon or Mars, careened through the disk on crossing orbits. They collided, shattered, and merged. The strongest embryos devoured the rest, clearing their orbits and swelling into true planets. In the third orbit from the sun, one of these survivors was winning. Blow by blow, impact by impact, it was becoming the Earth. But the newborn Earth was nothing like home. We call this age the Hadean, named for hell, and it earned the name. It was a glowing ball of molten rock, its surface a churning ocean of magma. Meteors rained down without pause, and the sky burned a hazy, poisonous red. The heat came from everywhere, the energy of endless impacts, and the decay of radioactive elements deep inside. Nothing solid could last. Nothing could live. A day lasted only a few hours, as the young planet spun wildly on its axis. This was Earth at its very beginning, violent, molten, and utterly alien. Because the whole planet was liquid, its ingredients could sort themselves by weight, in a process that still defines the Earth today. Heavy iron and nickel sank through the molten rock, drop by drop, sinking all the way to the center to form a dense metal core. Lighter rock floated upward to form the thick mantle around it. In this fiery sorting, the Earth gained the layered structure it still keeps 4 billion years later. Then came the most violent day our planet has ever known. Another young world, the size of Mars, was sharing Earth's neighborhood. We call it Theia. Their orbits could not last. In a colossal, glancing collision, Theia slammed into the Earth at thousands of miles an hour. The impact was almost unimaginable. It nearly shattered our planet, melting the surface and blasting a vast cloud of vaporized rock high into space. Earth survived, but forever changed, reformed as a spinning ball of molten rock, wrapped in a glowing ring of its own shattered debris. That ring of debris did not stay a ring for long. Within only a century or so, gravity pulled the fragments together into a single new body, the Moon. At first it hung enormous and close, a glowing molten disk filling the sky, far nearer than it is today. Slowly, over billions of years, it has been drifting away. And it was no idle companion. The Moon's gravity would come to steady the tilt of the Earth, calming our seasons and stabilizing our climate for eons to come. From the greatest catastrophe in Earth's history came the gentle light that would one day guide every tide, and every night sky. Destruction had created a guardian. With the giant impact behind it, the Earth began, at last, to cool. Slowly, a thin skin of dark solid rock hardened over the ocean of magma below. It was a fragile crust, cracked and remelted again and again by lingering impacts and the raging heat still trapped inside the planet. But it held. For the first time, the Earth had a surface. And from countless volcanoes, gases were pouring out to build something new, an atmosphere. Those volcanoes belched out enormous amounts of water vapor, along with carbon dioxide and nitrogen, thickening the young sky into a dense, steaming atmosphere. As the surface cooled below the boiling point, that vapor could finally condense. High in the sky, the first clouds formed. And then, it began to rain. It was a deluge beyond imagining, a downpour that may have lasted for centuries, even thousands of years, filling every basin and low place on Earth. Comets and icy asteroids added still more water from space. And so, on a young and battered planet, the first great oceans were born. But do not imagine a blue sky. The early atmosphere was thick, hazy, and utterly unbreathable, rich in carbon dioxide and other gases, with almost no oxygen at all. A human standing here would suffocate in moments beneath a dim, orange-tinted sky. This was a world of dark seas and toxic air. And yet, strangely, it was perfect. Warm, wet, and rich in chemistry, exactly the conditions where the next miracle could begin. The infant solar system was still dangerous. As the giant planets shifted in their orbits, their gravity flung swarms of asteroids and comets toward the inner worlds. For a long stretch of time, Earth and Moon were pounded by a storm of impacts, some large enough to boil the seas and reset the surface. The countless craters that scar the face of the Moon today are the frozen scars of this bombardment, a record Earth's living surface has long since erased. Beneath the young crust, the Earth was far from still. The immense heat trapped inside drove the rock of the mantle to churn in slow, powerful currents. This churning cracked the crust into enormous moving plates and set them drifting. Continents would collide and split, oceans open and close, mountains rise and fall. This restless engine, plate tectonics, would recycle the surface, regulate the climate over eons, and keep the Earth a living, dynamic world unlike any of its neighbors. Deep at the center, the swirling liquid iron core was doing something extraordinary. Its motion generated a vast, invisible magnetic field, reaching far out into space. That field became Earth's shield. It deflects the sun's deadly stream of charged particles, which would otherwise strip away our air and sterilize the surface. Without this hidden protection, Earth might have ended up barren like Mars. Instead, our shielded world kept its oceans and its air and its chance at life. In those early days, the Earth spun so fast that a full day lasted only about 6 hours. The newborn Moon hung huge and close in the sky. But the Moon's gravity gripped our oceans, raising great tides that dragged against the spinning planet, stealing its energy little by little. Across billions of years, this slowed the Earth's rotation to the 24-hour day we know, while the Moon drifted slowly outward, to where it rides today. Far out in the cold, the giant planet Jupiter was quietly shaping Earth's fate. Its immense gravity dominated the outer solar system. Like a great shepherd, Jupiter flung many wandering comets and asteroids away, and sometimes toward us, helping to sculpt the traffic of the early solar system. Some scientists believe this distant giant helped shield the inner worlds from countless impacts, giving fragile young Earth a steadier path toward life. Earth was not the only rocky world born from the disk. Its neighbors, Venus and Mars, began with the same ingredients and the same promise. But Venus, a little closer to the Sun, fell into a runaway greenhouse. Today it is a hellscape of crushing pressure and clouds of acid, hot enough to melt lead. Mars, smaller and farther out, once had rivers and lakes, but it lost its magnetic field, and its air and water bled away into space, leaving a frozen desert. Only Earth, in the narrow band where water stays liquid, held on to its oceans and its air. 3 sister worlds, and only one became a garden. How do we know any of this? Because the Earth keeps records, written in stone. In the oldest rocks, tiny crystals called zircons have survived for over 4 billion years. These microscopic time capsules are the most ancient pieces of our planet ever found, and they whisper of liquid water on Earth far earlier than we once believed. From the chemistry locked inside them, we read the story of a young world that cooled and gained oceans, astonishingly soon after it was born. Gradually, over hundreds of millions of years, the fury subsided. The bombardment eased, the oceans stilled, and the first small continents rose above the global sea. Earth had found its place, not too hot, not too cold, with liquid water, a protective atmosphere, a magnetic shield, and a steadying moon. A stable, watery world now turned quietly in the sunlight, no longer a hell, but not yet a home. Just a planet, waiting. Everything was ready. In the warm, chemical-rich waters of this young world, the stage was set for the most extraordinary event of all, the beginning of life.